Today we're looking at reacting volumes. This is very similar to reacting masses, but more useful when you have a gas in your equation, such as oxygen. It's very similar to reacting masses, but it's even easier. This is because when we think about molar masses, we have to go to the periodic table, find out the masses of each individual atom and add them all together to get an overall mass of each compound. With molar volumes, we look at this statement. All gases occupy the same volume at a certain temperature and pressure. That means at a particular temperature, 1 mole of any gas will occupy the same volume. So at room temperature, 1 mole of carbon dioxide occupies 24 decimeters cubed. 1 mole of methane also occupies 24 decimeters cubed. Even though the two have very different molar masses, they have the same molar volume. They occupy the same space, and that would be true of any gas. Most experiments that you see in your exams will be done at room temperature, and therefore the molar volume will be 24 decimeters cubed. That means that any gas will have a molar volume of 24 decimeters cubed. Let's have a look at how that applies to a question. I have 32 grams of methane. What volume of oxygen will I need? We start in the same way that we do reacting masses. We balance the equation first. We've got 1 carbon here and 1 carbon there, 4 hydrogens, so we need 2 lots of water. Now we have 2 oxygens and 2 oxygens, so we need 2 lots of O2. That's now balanced. Now we look at our question and find out what information we are given. We have 32 grams of methane. What volume of oxygen will I need? That's a volume, not a mass. We do what we've done so far with reacting masses. So firstly, we need the molar mass, because we're working in masses of methane. So CH4, 1 carbon, 4 hydrogens, that's 16 grams is the molar mass from the periodic table. When we work out the moles, 32 divided by 16 gives us 2 moles of methane. The ratio comes from balancing the equation. It's 1 molecule of methane reacts with 2 molecules of oxygen. 2 molecules would react with 4 molecules. 1 mole reacts with 2 moles, and that's our ratio, 1 to 2. So the equation is 1 to 2 in terms of balancing. That means that when we look at the moles we've actually got in 32 grams, 2 moles would react with 4 moles of oxygen. 1 to 2, 2 to 4. So we have 4 moles of oxygen that we need. Now we need to turn that mole value into a volume, and we can use our equation down here. Okay, if we have 4 moles, we know that the molar volume, we're working in volume this time, so we need the molar volume instead of the molar mass. We know the molar volume of any gas is 24 decimeters cubed at room temperature and pressure. If we have 4 moles, each with a volume of 24 decimeters cubed, we do 4 times 24, and that gives us our answer of 96 decimeters cubed. And that will be the volume of oxygen required to react with 32 grams of methane. So there is our answer.